Next topic is WebSocket. Okay, so let's start with the presentation. So we are going to talk about what is and why you want to use a WebSocket, and we are going to take a look at the WebSocket protocol and how things are being, exchanged, what things are being exchanged between client and server. And we are going to see WebSocket client API, and then we are going to see server-side implementations. And we are going to see also high-level protocols, or WebSocket specification says subprotocols. These are the protocols that are built on the top of WebSocket. So what is and why WebSocket? If you think about the characteristics of modern applications, modern web applications, these are the characteristics. They are collaborative, so meaning many participants access the same application. And the participatory content generation, so participants post contents. So Twitter and the Facebook or the Flickr, these are the applications where participants are in fact the ones that create contents and post them, and those contents are being viewed, and sometimes you are going to actually communicate. The Google Talk and the Skype. These are in fact the participants also actually creating contents, also participating in communication. Real time. So contents are published and distributed real time, and multi-device and mobile friendly. So applications are accessed through many different client types, which include desktop browser, tablet, mobile phones, and TVs, and things like that. So examples of modern web applications include online gaming, where many participants are actually playing together, and the distance learning. So there could be many students and several instructors all interacting each other in real-time basis. And collaborative authoring. So if you're writing document using Google Apps, basically multiple authors are actually changing the same content at the same time, and changes are being reflected in real time to everyone. And auctions. So if you're using eBay, you want to make, if you're actually bidding something, you want to actually get the bidding information from others on real-time basis, right? Okay. So these are the examples of all modern web applications, reflecting those characteristics we talked about in previous slide. So what are the requirements to make these applications with these characteristics? So modern web applications demand these features: reliable communication, and real-time or event-driven communication, meaning whenever something interesting happens, that the information has to be propagated to everyone participating in that communication. And bidirectional communication is not just from the browser to the server, but from the server to the client, meaning the server wants to propagate the data to every participant, meaning every client, when it wants to. Okay. These things to be done with minimum latency and with a minimum overhead. So the current technology before WebSocket, for that matter, before HTML5, did not really meet these requirements. Okay, so these are in fact the problems of HTTP. So it is a half duplex, so traffic flows in only one direction at a time. Okay. So in order to have a full duplex communication, things has to be kind of hacked. Okay. And it has high overhead. So if you actually send the HTTP request and response, the header structures contains a lot of overhead. Okay, and that header structure overhead is actually for every single HTTP request and response. So that could be huge. So if you are sending just a single bit, you still have to actually endure. You still have to actually have the overhead of the HTTP headers. And it is slow because of the higher overhead involved in terms of size, and it requires complex hacks to achieve real-time bidirectional communication. So because of these limitations, in order to actually achieve bidirectional full duplex communication, people have to people have to come up with some hacks like a Comet. So Comet is a technology that is used to allow the server to propagate the data to many clients when it wants to, and but it is actually a hack basically. Okay, so without the hack like a Comet, clients have to poll the server. So without using hack like Comet, the other option clients have is just polling, and the polling has a lot of disadvantages. Okay, so just to give you a sense of how Comet is in fact working, so complex hacks to achieve real time. Again, this is before WebSockets is being used. One option is using polling, so client just keep polling every few seconds, every some interval. And client has to wait until response comes back from the server. And so long polling, on the other hand, is called it is actually called a Comet. It uses two connections, and it adds complexity to both client and server, meaning client code and the server code has to be in fact commetized basically to support this Comet feature to have this the bidirectional communication. All right. So let's actually see. So that's the reason we need to have some new scheme, and that's basically WebSocket. So what you're going to do now is we're going to actually see some WebSocket examples. Okay, so these are typical examples that you could actually use this real-time bidirectional communication. Okay, so let's go to exercise 1. Experiment with some sample WebSocket applications. So you can write this application using Comet, or you can use with a WebSocket. And this is actually written in WebSocket. And basically, this is actually an application where many participants. So this is actually a stock portfolio demo. So this company called Kazin, they are actually pretty big on the WebSocket community. So you can actually go to this website and select it, or you can go directly to portfolio. So this portfolio, basically, the stock information is being distributed to many participants. Okay. Now you can actually open another client. So I'm going to actually open another client. In this case, I'm going to just open another browser. Okay. Just simulating another user. Okay. So I'm going to have this portfolio right here. And you can see the same data is actually being exchanged. Okay. Now, if you are making, let's say you try to buy, you buy 1,000 shares of 3Com. Okay, and then the basically that shares is already being seen by someone else. Okay, so I mean we have only 2 users being simulated on the same machine here, but these users could be 3,000 miles away. Okay, and there could be in fact tens of thousands of users accessing the same application. They are all being propagated with the same data. Okay, so whenever this user make a purchase, so again buy 2,000 shares, and say buy 2,000 shares, and okay, then that information is actually propagated. Did I do that? Okay. Why it doesn't actually take me? Yeah. Okay, I'm not sure this is actually Firefox issue. So let me actually just try this one again. 2,000 shares, and click OK. I'm not sure whether this is the issue of the application itself. Okay, so that worked. Okay, so now you can see this one is done. So I'm gonna actually buy from here 3,000 shares, and okay, and okay, yeah. Let me see whether this one works. Yeah, I'm not sure what the deal with this is. I mean, the point is that whatever one client make a change, that is actually propagated to everyone else. Okay, so that is the point. Okay. So that's one application. Now the second application, this is in fact the we're gonna actually play around the actual code. This is a chatting application. Okay, so you can actually go to here. In fact, if you go on this website, okay, you can actually join. So I'm gonna just choose my name, Sang, and you can see Sang has been yeah. So Sang should have joined. Yeah, so now I'm gonna actually post a message. My first message. Okay, so my first message is posted. So you guys can actually go to this website, and if you actually post a message, then everyone involved right now, I'm not sure how many people actually online, they all see these messages. Okay, so I'm gonna say teaching 3-day HTML5 code camp JPassion.com code camps. Okay, all right. So my message is being seen by everyone. Okay, so if I actually go to another browser, just again simulating another user, and I'm gonna this time using different username. Okay, so I'm gonna go to yeah, so this is the same URL. So here I'm gonna go over there. And here, so you can see, this user actually seeing the messages that I posted before. So I'm going to actually choose another name, okay? JPassion.com 2, and enter. And then I'm going to actually send another message. This is a message, test message from second user of JPassion.com. Okay, and if I go to the previous user, I should actually see that message that is posted by that second user. Okay, and you can see the message is being posted by other people. Okay, all right, so this is a sample application. In fact, we're going to actually kind of modify later on. Okay, so that is another sample application. We just did that. Okay, so yeah, so I'm going to actually move on to the next presentation topic, and I'll give you about 10 or 15 minutes after this. Okay, so let's see. So let's talk about what is NY WebSockets. So it provides a full duplex bidirectional communication channel over a single socket. So both client and server can send data at any time and at the same time. Okay, so in HTTP before, only one side can send the data at a single point in time, but using WebSocket, both client and server can send data at any time in either direction. And it has a much lower overhead. So data is sent without the overhead of HTTP headers, and we're going to actually see what size advantage it has over HTTP. It works with the firewalls and proxies, and in fact, it will actually use HTTP as a handshake. Okay, so initially it will use HTTP to negotiate with the server whether the server can handle WebSocket or not. Okay, so because it's using HTTP as an initial handshake, it should work with the firewall and proxies. And it integrates with a cookie-based authentication because again it's using HTTP. So in terms of actually doing some kind of authentication with a WebSocket server, they could actually use the existing scheme based on HTTP. So it replaces Comet. Okay, so no more complexity needed for the server sending data to the client. Okay, and it is cross-domain capable through CORS, so it is secure. And again, we'll talk about the CORS later on in detail in the next presentation after this. So let's see browser support of WebSocket. So go to this caniuse.com, and if you search for WebSocket, the support is about 69%. Okay, so that's not bad. Okay, so let's talk about the WebSocket protocol. So connection establishment, initial phase of connection establishment is done through HTTP. Okay, so it's actually using same TCP connection. In terms of protocol, WebSockets using WS. Okay, and the secure WebSockets using WSS. Okay, so when WS is actually being, any page that contain any URL that starts with a WS, it's going to use underneath HTTP to negotiate whether the partner can actually support WebSocket or not. If they do, then they're going to actually use WebSocket after that. Okay, we're going to actually see this connection establishment scheme in a second. So WebSocket has lower overhead, okay, because each message, this message could be called, sometimes called a frame, has only 2 bytes of overhead for messages whose length is 126 bytes and under. So in many cases, you are sending, very short messages, and those short messages, which is 126 bytes and under, has only 2 bytes overhead. Okay, if the message is bigger than that, then it'll have the couple more bytes describing the length. Okay, there is no latency in establishing new TCP connection for each HTTP message. So so the time that is being saved is significant. So reducing from 150 milliseconds to 50 milliseconds. Okay. And there is no polling overhead. So client and server send messages only when there is something to send. They're not going to actually send anything unless there is actually something to send. Okay, unlike polling. Okay, so upgrade client server handshake. Yeah, so basically initially it's going to use HTTP. Client will send HTTP request. Asking the server whether the server can handle WebSocket. So this is the HTTP, the headers containing the WebSocket request in a sense. Okay, so you can see connection upgrade. Okay, that means I want to upgrade to WebSocket. Okay, so if the server received this one, and if the server can support WebSocket, then it will send back this response. Okay, so this is actually response over HTTP. Okay, so upgrade, and after that they will communicate through WebSocket. Okay, so the first exchange is done through HTTP request and header, but after that, it will be using WebSocket. Okay. Now, in terms of data frame structure, this is how message is going to look like. Okay, so the first 2 bytes is the opcode. Opcode contains the first bit is actually the bit indicating whether this fragment is a final fragment or not. So you could actually have a message that is constructed with multiple fragments. Okay, if it is the 1, it indicates a final fragment. Okay, if it is 0, that means it's actually a fragment of a fragment of a message. Okay, and then it contains 4-bit opcode. So 1 means it is a text. 2 means it's a binary, and 8 is a close, and 9 is a ping, and 10 is a pong. Okay, and now is masked here is masked bit, and it's basically indicating if this frame is masked or not. Okay, yeah. So this mask thing is actually designed because some community members actually raised security issues with the previous data structure, and so they came up with this mask things. So just for now, you can think of this mask is security related. Okay, that's good enough for now. Okay, so let's do exercise 2. So exercise 2, we are going to observe the WebSocket handshake. Okay, so let's take a look at the so what we're going to do is we are going to send the request to this echo test. This is the WebSocket server. So there is a website called the WebSocket.org, and if you go over here, and you can actually connect. Okay, and it's connected, and you can send a message, and the message is JPassion.com WebSocket message, and send, and the server is going to just respond. Okay, and I can send it, and the server kind of respond. So what we want to do is we want to actually see the exchange. So let's actually open developer tool. So open developer tool here, and take a look at the network. Select network here. And now let's actually start from the beginning. So we're going to actually disconnect again, and then try to connect. Okay, so now you can see message is captured. So we are going to actually see this message, and we're going to actually see the headers. So you can see we have request headers, and we have response headers. So request header is basically sending a message to this host, and basically it says connection upgrade. So this is an indication to the server that the client wants to do WebSocket communication. So in this case, the server will respond with the connection upgrade. That means server is capable of WebSocket and server is ready to do WebSocket communication with this particular client. Okay, and then the client can send a message and things like that. Okay, so that's basically the capturing initial handshake with the server, between the client and server. Okay, so that is the exercise 2. Frame. So you also actually can see the data that is being exchanged. Okay, so let me actually show that one as well. Okay, and then we're gonna actually disconnect, and disconnect. You can see it's sending opcode 8, which is close, and then the So all right, so let's actually show the data frame. I'm gonna start it again. Go to this website. Okay, and we are going to open developer tools and connection. Okay, and then we are going to send some messages. So in order to capture these messages, you have to select WebSocket here. Okay, so select WebSocket. Okay, and send some messages. Okay, and response, and select WebSocket, and I have to actually select this one first, and then WebSocket, and then take a look at the frame. Okay, so you can see the messages being captured. Okay, so I'm going to send a message sending JPassion.com and send, and then if you let me see. And let me just refresh why it didn't actually. Okay, so I'm going to try again. I'll connect, and I'm going to send JPassion.com, send it. Okay, and now select this one. Okay, so now you can see the data is actually being captured. Okay, now I'm going to disconnect. Okay, and it looks like I have to actually click this one to see the data that is being exchanged. So you can see the opcode. Yes, this is request and this is response. Okay, so that is an exercise. All right, so I'm gonna give you guys 10 minutes to do exercise 1 and 2. Okay. Okay, so now we're going to actually learn WebSocket Client API. So we have seen real-life examples, and we have seen the interaction between client and server. So let's see how we can actually write the client-side code that actually perform this WebSocket communication between client and server. So the APIs are very, very simple. So you're going to create a WebSocket first, okay? And there are few ways that you can create a WebSocket. Basically, you're going to use a WebSocket. You're going to create a WebSocket like a new WebSocket and provide the URL of the server. Okay. You can actually specify optional higher-level protocol like a stump. Okay. Or you can actually provide multiple protocols like stump and my protocol as an array. Or you can create SSL. Okay, so in our previous example, when you actually select, when you click this one, it's actually basically sending the request to WSS. Okay, so that's basically what's happening. Okay, so once you create the WebSocket object, and then you are going to have event handlers. So onOpen event handler is event handler that gets called when the connection is established. Okay. And then onMessage is that whenever message is received from the server, this event handler will be displayed. So here is going to just display the data that is received. And onClose is that when the connection is closed, then this event handler gets invoked. When there is an error, then this is what gets invoked. Okay. So in this case, when we can actually send a message. We can send a message when the connection is established. So this is event handler indicating the connection has been successfully established, then we just send a message. Okay, so in terms of sending a message, you can call send method, okay, and you can also send a binary message. So you create new blob, okay, and then you can send that blob object, okay. And to close a connection, you call close method. So you can see the APIs are extremely simple to use. All right, so let's actually do exercise 3. So exercise 3 is so here we are going to actually invoke this echo. Oh yeah, this is exercise 2. I want to actually go to exercise 3. Okay, so we are going to actually access this client. So in this the HTML file, we are going to access the same website that we invoked. We actually talked in exercise 2, but we are using our own code. Okay, so if you take a look at this code, let's actually run this one first. Okay, so here we run it and we can connect it, and then we can send a message. Okay, message number 1, message number 2, and message number 3, and then we can disconnect. Okay, so we are talking to the same server, echo WebSocket, websocket.org, but we are actually using our own code. Okay, so let's take a look at the code. So again, we can actually see handshaking. Okay, and we actually send a message and then we disconnect. Okay, and oh wait a minute, we are looking at. Okay, so I'm supposed to, I'm actually looking at the exercise 3, okay, not 4. So this is the client code. So as you can see, when you click the connect, this connect handler gets called. This connect function gets called, and here we create the WebSocket object first, and that URL is here. Okay, and so once you got the WebSocket object, we associate it with event handler. When the successful establishment, we'll call this handler. So we are going to display connect to, and then we just display the the state, ready state. And then on message, whenever we receive the message from the server, we are going to display the message, the color blue, and and the data, and then we're going to just say response. Okay, so that's what you are going to see here. Okay, response, and then message number 2. So that's what comes back from the server. And then so this is on close on message, and disconnect is we can just close the connection. Okay, send message is basically send a message. Okay, so we are sending a message number with message number, and send a message. Okay, so very simple code. All right. So I'm gonna let you guys to play with this just a few minutes. Okay, and then we're gonna move on to exercise 4, in which we are going to see how we can implement our own server. Okay, so that's a little bit big subject. So let's actually do exercise 3 first. So next topic is a server implementation, server-side implementation. So there are many different the server-side implementations. In Java space, you could use Java EE7 at WebSocket annotation. There is a JWebSocket library, and Jetty has WebSocket Servlet. So multiple implementations in Java space. You could have PHP WebSockets. Or you can use a Node.js, so that's actually something that we are going to actually use in our hands-on lab. But pretty much, any server-side framework will have a WebSocket support. Okay. All right, so let's do exercise 4. So we can actually do exercise 4 and 5. So let me actually explain, and I'll give you plenty of time to play with this. Okay. So let's go to exercise 4. So exercise 4, we are going to install the Node.js because that is what we are going to use. So install Node.js. So you go to nodejs.org download site, and you're going to actually download your platform's Node.js and install it. And you might want to add Node.js home directory. Once you installed it, Node.js home directory in your path. Add it to your path so that you can actually run node command at the terminal window. Okay, so in my case, I've done that already, so I can just say node version, and it should give me the version. So if you actually see command not found or something like that, that means you don't have the node directory in your path. Okay, so I can display help screen of the node command. Okay, so that is node installation, and node is actually plugin based. So every feature of Node.js is through the plugin. So here we are going to install the WebSocket plugin. Okay, so you are going to say npm. So npm is actually from the node package. So if I'm gonna actually find out node, you can see it is actually under the node package. Okay, so if I go to Node.js, this is where I install the Node.js. And so npm, so this is the Windows version. This is the Linux and Mac OS version. So npm is the node package manager. Okay, so through the npm command you can install plugins. So here we are going to install the WebSocket plugin. So the command you're going to use is npm install WebSocket. Okay, then it's gonna download the WebSocket from the web server, and then it will install it. Okay, and then you can actually should be able to list all the so npm pm list plugins. Then it will display all the plugins that have been installed. So in my case, it should have been installed already. So okay, so looks like I got the wrong command. npm I forgot the command. I think I have a documentation somewhere. Okay, so once you installed it, it should be installed. Okay, and then you are going to run Node.js WebSocket server and client. So go to the directory of samples underscore HTML5 and node echo node.js. So I'm gonna actually go over there. So first of all, yeah, you want to actually disconnect all. You want to actually remove, stop the HTTP server that you are running in previous exercise. So I'm going to make sure I'm not running anything. And okay, so I'm gonna actually go to the echo node.js directory. So I'm gonna go to H5 and HTML5 and WebSocket, and go to samples HTML5, and you are going to see the echo node.js. Okay, so go to cd echo node.js, and now you're gonna actually run the server. So you're gonna say node and echo server.js. Okay, so now you're running the WebSocket server application. So this is actually echo server that does what the in exercise 2 and 3 did. Okay, but we are running on our own server. Okay, all right. Now, by the way, if you experience listen EADDR in use error message, that means you're actually using port number 8000, which means that you have not actually stopped your previous HTTP server. So make sure you stop the old HTTP servers before you are running the echo server here. And I think it's using port number. Oh, this is actually using port number 8080. Okay. All right, now we can open the client. So I'm going to actually open this guy, and here now I can actually connect to this guy. So it's connecting it, it's connected. Then I can send a message. Okay, you can see the interaction is exactly the same as we have seen in exercise 2 and 3, right? Okay, and then I can disconnect. But it's talking to my own server, which is running on port number 8080. Okay, all right. So that, and of course you can actually see the interaction here. Okay, and here you can see the protocol is echo protocol. Okay, so this is something we're going to actually talk about later on, be more details. So, don't worry about that. So we send the messages and then we disconnect. Okay, and you can see on the console that in fact the connection was created and then message has been received. I send the 3 messages, so the server says it received the 3 messages. Okay. All right, now let's take a look at the code. So this is the echoserver.js file. So this is the Node.js code. Okay. So what it does is that it creates the WebSocket server object. So this is from the WebSocket plugin, okay, and it's using HTTP server underneath, and then auto accept connection is false, okay, and then this code it will actually receive the connection request accept, and then it's basically whenever it's receiving the message, okay, whether it's in fact the UTF-8 or binary, it will just send back the different message, different the response, okay, and when it's closed, it will just say closed. Okay, so basically when it closes, I mean these are the messages that are being displayed from here. Okay, so when message is received, it will display receive message, and that is this one. Okay, so when things get disconnected, let's actually disconnect it. Oops. Yeah, so when you actually disconnect, we're gonna actually see it's actually disconnected. So this is a server-side code. Okay. Now exercise 5 is client-side code. Okay. So the we were running client-side code, right? And so basically we have the chat Node.js directory. Oh, wait a minute. Okay, so this is actually the socket, just the messaging things. Okay, exercise 5. This is another sample application. Okay, so this is a chat server application. So here we are going to actually run the chat server. So stop the this echo server first. Stop the echo server and then go to different directory. And here we are going to run we're going to go to the directory. And we are going to have a chat application. So go to chat Node.js, and now we are going to actually run node chat server.js. Okay, and so the server application is running, and then we are going to actually run the client code. So this is actually chatting application that we exercised in exercise 1. So run this client code. Now I'm going to actually add my my name. So Sang Shin, and Sang Shin has been added, and I'm going to send a message 1, something like that. Now I'm going to simulate the second user. So I'm going to open the another browser here, and here I'm going to set URL here. And so you can see, the messages that have been posted by other users should be actually displayed for me. And this is Sang2. Okay, so Sang2 joined, and Sang2 send the message JPassion.com code camp day 2. Okay, and this user should actually see that message. Okay, and also each user has a different color. Okay, so that is a code. So that is basically what's happening. Okay. Now let's take a look at the code. So here we have global variables of history as an array and clients an array. So history is the one that contains all the messages that have been posted by all the users. And the clients, this is the list of all the clients. Okay, so any users that have been joined will be maintained in this array. Okay. And then on the server side, basically send back. Yeah, so the send back chat history. So when the new user has been, when the new user is actually joined, the history, chat history will be sent. So basically, we check whether any messages has been posted by checking the length of the history array, and then we are basically creating a string of the history and data. Okay, so you basically type is history and the data is history array object. Okay, so the client will actually receive the history object. So when the new user actually joined, the new user actually see all these messages, right? So that is coming from here. And this one is the when user sent the message. Okay, it check whether it is actually UTF message or not. And so accept only text. Yeah, looks like that's the only thing that is actually checking here. So here, basically what it does is that it just get the color, and then it sends the the user color. So it sends the data. The type is color, and the data is user color. So each user will have a different color. Okay, and the message to display is that join the chat. Okay. Okay. So this is basically when the username is false, that means it's a message joining. It's a message that indicating the user wants to join. If it is not false, that means it's a regular message. So here we are basically displaying received message and message that has been received. Okay, and then what it does is that it create those things, and then it will just broadcast that messages to all the clients. So all the clients are actually in the clients array, right? So it actually goes through all the clients in the client array, and then just send this JSON object, which is a message, and the message contains the whatever message. This message could be either someone joined or it's a message that has been posted. Okay, so relatively straightforward server-side code. Okay, now this is a client-side code. So this is the HTML file that actually invokes the client.js file. So client.js file, again, is relatively straightforward. So it's actually creating a WebSocket object on this port number 1337, and then it does have an onOpen and onError and onMessage. So onOpen is basically, when the connection has been established, it will just display the choose name. So user will choose a name, okay? And the on message is whenever something is received from the server, this on message handler, this function will be invoked, and it's going to actually check, the type of it. Type could be either color or history or message, right? So the color is actually to displaying the color, so different color will be displayed, right? And type is history, that means all the message history will be displayed. And if it is a message, then it's just a message being displayed, okay? And this one is just to send a message. Whenever the user is actually sending a message, it will actually invoke the key down. So key down, it will actually call this function, and it will just send a message. Okay. All right. So I feel like I'm kind of rushing a little bit, which I shouldn't have to. Okay, because we have plenty of time. But I'm gonna give you guys enough time on this. And in fact, we have a 3 o'clock, and let's have 10 minutes, break as well. So I'm going to give you guys about the 20 minutes for this exercise, 4 and 5, and let's have 10 minutes break. So we will be back 30 minutes after 3 o'clock. The last topic of WebSocket is a WebSocket higher level protocols. Okay. So examples of higher level protocols on the top of WebSockets include XMPP. This is for instant messaging, and the actual implementation could be like a Java. Java is an example implementation of XMPP, and pops up the communication model, in this case messaging, so STUMP or AMQP. So those are the example implementations. Supporting pops up messaging model. So you can think of these high-level protocols of WebSocket in the same way. If you think about TCP, there are high-level protocols on the top of TCP, like SMTP or FTP. Those are high-level protocols that are built on the top of TCP, right? So you can think of this XMPP or PubSub or many other, the high-level protocols that are built on the top of the WebSocket. All right, so we are going to do exercise 6. So this one is in fact involved the STUMP. Okay, so let me explain this exercise, and I'll give you plenty of time. So we are going to actually use ActiveMQ, which is a messaging server. This messaging server, ActiveMQ messaging server, provides messaging that are running on the top of WebSocket. Okay. So go to this website and download the message MQ. Okay, and you can download Windows and Unix and Linux version here. Okay, and unzip the package and include the bin directory of that installation to your path so that you can actually call this command. Okay, so I'm going to actually follow this. So I'm gonna go to, let me just stop this guy. So I'm gonna go to Apache ActiveMQ directory that I have installed. Okay, so I have already installed it here. And then I'm going to start the ActiveMQ server. So ActiveMQ lets you in fact start the server with a different configuration. So the configuration that you want to start with is this ActiveMQ demo.xml file. So this configuration file actually is used to indicate to ActiveMQ to start with some the demo packages. Okay, so I'm going to start this. So you can just copy this command, right? So I'm actually starting ActiveMQ. Okay, all right, and allow access. Okay, so ActiveMQ is now up and running. Okay. Now I can go to this. I can go to my browser. So so now it's ready. So it should be yeah. So Apache, Camel, and everything. I mean everything is actually now started. Now I can go to this browser, local host 8161. That's in fact the admin, okay, of ActiveMQ. Okay. So the default admin username and password is admin. So I just so admin and admin. Okay, let me just go and then click the see some web demos. Okay, so let's actually do that first. Okay, so I'm gonna go over here and type admin, and now logged in. Okay, so now we are logged in, and then you are going to see some web demos. Okay, so click this one. So now we can see there are a bunch of demos, and one of the demos is in fact the WebSocket example. Okay, so let me actually go back to the lab documentation. Okay, so when you click WebSocket, okay, it's going to actually provide server URL. Okay, so this is the the Stump messaging server. So you are actually connecting to the messaging server with the guest and guest. Okay, and the destination is a queue to test. In fact, yeah. So this is basically it's not using PubSub publish and subscribe model. This is actually using point model. Okay, so the name of the destination is queue test. So this is going to connect. So if you click connect, okay, and then if you actually see the what's happening using developer tools, and you are going to actually see the messages being exchanged, and of course this is actually starting to make a connection to WebSocket server, and these are in fact the messages. These are high level. So WebSocket opened and connected. Yeah, so this is in fact the messages that are displaying the WebSocket handshake. In fact, okay. All right. Now what you can do is that so you can obviously see over here as well. Now this is actually interesting. So the client was actually sending the protocols they can support. So it wants to. The client says I can support version 10 of Stump and version 11 of Stump. The server responds back, I can actually support only version 10. So the server sends back, with the version 10 of Stump. Okay, so this WebSocket protocol indicates what is the high-level protocols they want to actually use. Okay. And so if you take a look at the frames, so these are actually the messages level. So these are the messages. Okay, so you can see the subscribe message. Okay, and now you can actually send a message. So you can actually send a message, hello JPassion. Now because there is only one client, this message will be received by this one client. Okay, so you can actually see the message being displayed. Now, if you open another client, okay, so providing the same URL, now we have another client connecting to that the destination. So this is a point-to-point. So in the point-to-point messaging, the message will be consumed by a single user. That's actually point-to-point messaging model. Okay, in the publish and subscribe model, there could be actually multiple consumers for a single message. But in the point-point, a message will be consumed only by one user. So when you have two users, then so we have the message, the client number 2. Okay, now when the message is actually being sent from one client, then it's going to be consumed by the other client. Okay. Instead of actually it's consumed by the self. So when you have a single client, that single client will actually send it and it will consume it. But when you have two clients, the message sent by one client will be consumed by the other client. So that's basically what's happening here. So you're going to send a message from client 1 to 2. Okay, so message from client 1 and 2. And then client 2 is going to receive the message. Because this message is consumed by client 2, the first client will not, the client number 1 will not actually have a chance to consume it. Same thing, from if you actually send a message from client 2 to client 1, that will be consumed by client 1. So let me do these things step by step. I just want to actually explaining it. Okay, so we have done, this one, I want to just go over here. Okay, so I'm going to click the WebSocket here, and I'm going to use the same link connect. Okay, so the client 1 is now started. Okay, so I can just type a message 1 from myself. Okay, and then I can send it. So you can see the message is consumed by this guy because there is only one client. Okay, so now we're going to actually create another client. So I'm going to just open another browser, in this case Firefox. So this is client number 2 accessing the same. Is that guest to guest? Okay, so maybe guest to guest. Same, the queue. Oh, this is not okay. So what is the maybe admin. Let me see. Admin. Okay, good. So is that in fact admin? So I'm going to, this client number 2 is going to connect. Okay. So this guy is, so we have, let me actually, so we have, this is client number 1, this is client number 2. Now let's actually try to send a message. Message number 2 from client 1. Now this message, this guy is actually consumed by itself. I expected this one is actually consuming. Okay, so let's actually try to send a message from this guy. And hello 1 from client 2. I expected they actually supposed to send the messages back and forth, but looks like they're not. Yeah, it seems like they're not actually talking to the same the queue. Okay, so let me disconnect, and so yeah, it is actually the same destination queue test. Oh, okay, so this time it seems to work. Yeah, so I send a message and then this guy actually receive it. So so I'm gonna just send one more message. Message from client 1 XXX or something like that, and then send the message, and now this guy actually received it. Okay, now the claim, I'm gonna actually send a message from client 2, JPassion.com rocks. Okay, and then you can see this guy actually received the message. Okay, all right, so that's the lab, and yeah, so I'm gonna give you about 15 minutes to do this exercise.